Welcome to the Living in the Future podcast, where we bring to light specialized topics from life in the modern age. This episode, I'll be talking to two developers who are recreating historically significant computers in a way that allows people to try them out inexpensively and easily. I'm talking to Oscar Vermeulen. He is the creator of the Pidp-8 and Pidp-11 projects, which allow builders to create replicas of vintage computers from the 1960s and 70s that played critical roles in computer history. Oscar, how did you come up with the idea to do the kit?
Well, there's a bit of background there. I'm at the age of 50, actually still too young to have really lived the era of mini computers before microcomputers. Like you say, that was the 60s and 70s. But as a kid of, like, say, 16, 17 years old, like most at the time in the early 80s, I got my Commodore 64, discovered that expanding that thing was pretty expensive. And actually, you got very interesting cheap computers if you just knocked on the door of companies and asked them, if you could have their old obsolete computers. Because certainly in the 80s, computing machinery got exchanged every few years. That ended up being a sort of a fascination with older systems and computers. And so for many years, I collected computers. But I always shied away from these mini computers that existed before the time of the microprocessor. So call it before 1976, 1977. These machines were huge, right? And they're the size of a couple of bookshelves at least. They look pretty intimidating. There's tons of parts in there. They weigh hundreds of pounds. So I always sort of shied away from them and kept collecting the simpler mini computers. And then, more and more of my friends started to delve into these mini computers, started to restore them, repair them. And as it turned out, as of, let's say, the last 10 years, running mini computers became pretty expensive collectible items. So I decided that was a bit above budget. And why not just, make myself a little fake mini computer that was actually portable, but still looked the part. And that's why I, in the end, basically made a fake little replica mini computer. That was the Pidp-8. And I thought, maybe there's a couple of other fools that are interested in this. Maybe I'm not the only one. So I got 50 front panels, 50 parts of the kit. And before I knew it, I think there's like 3,000 or so sold by now. It turns out that there's a huge community of people that are either curious from a computer history perspective, or nostalgic at a certain age and are interested in these machines.
They're not only functional, but they're also fantastic design pieces as well. They look, they have a very vintage look to them. That's very interesting.
Yeah, and truth be told, there's, I think, two reasons to be interested in mini computers. The simple one is because of their aesthetic. The way they look, they have a very 60s or typically mid 70s design with the color scheme to match and whatnot. And there's a certain retro attractiveness to that. The blinking lights on the front panel clearly add massively to that. And there's a second reason to be fascinated by them as well. Something that got lost in the microcomputer revolution that followed from the mid to late 70s on. With microcomputers, basically the CPU, the processor, is one chip. And there's no way to look into it. You only get stuff coming out of there. These old mini computers were not built with microprocessors. They were built with either transistors and diodes or very simple chips. But you could tap into all the signals, all the electrical signals that are sent to and fro within the processing unit. And that's what actually brought to the front panel, to these blinking lights on the front panel. And so as an educational tool to understand what the heck is a processor, what does it do, it's interesting because all these blinky lights give you an exact picture of what's going on inside the machine. And so I think next to the aesthetic aspect, there's also this aspect of, okay, this is a machine that you can truly understand from the single bit upward. So there's a certain educational aspect to this hobby as well, I think.
And I mean, these are critical mini computers that you're recreating. I think the Pidp-11 is a little more famous than the 8. Would you talk about, I guess, a little bit about the role of Pidp-11 in, I guess, Bell Labs history and Unix history?
Yeah, but let me maybe take a step back further in history and sort of give you the progression. So you had the very first computers in the 40s, the ENIAC and those sort of machines. And fairly quickly afterwards, room-sized computers were built, called them mini computers if you want. The Pidp-1 was a famous one in the MIT labs. Around that time also the whole hacker ethic emerged. The whole idea of your programming for maybe open source was not a known word then, but the whole idea of this is a collaborative effort, let's be open, share information, that really rose out of the MIT labs in Boston. You had some earlier machines, but they were all impossibly expensive. And then by 1965, Digital Equipment Corporation came out with the Pidp-8, and actually they slightly tricked their investors by calling it a PDP, a programmable data processor, because they realized if they called it a computer, that would be kind of off-putting to investors at the time. Can you really make a small computer? Is this serious or not? It sounds risky. So they called it the PDP, and the whole PDP series kept that moniker. The Pidp-8 was really a very simple machine. You could compare it to, if you know those things, the Arduino microcontroller that you can buy these days, all these very simple machines. Amazingly, its CPU only had 8 instructions. The whole thing had a maximum of 32K of memory, call it RAM. But with that, you could do simple things like automate toll booths, automate rocket launching systems, run simple administrations, do physics research, all that kind of stuff. Technology clearly sort of raced ahead in those years, and so in '65 the first Pidp-8 was brought out, and in 1970 the first Pidp-11, and the 11 was massive because the way they designed the CPU, the processor, kind of influenced literally everything that came afterwards. If you look at modern microprocessors, a lot of the ideas, the way they operate specifically, came out of the Pidp-11. DEC itself, Digital Equipment Corporation itself, had its own set of operating systems, and the machines were used, to control everything from nuclear power plants to hospital administrations. They really were used in every imaginable context, both as microcontrollers, call it industrial controllers, as precursors of the personal computer, or even as competition to mainframe computers of IBM at the time. So they were used everywhere. That was amazing. Like you said, in Bell Labs at the same time, they had a couple of PDP machines standing there. One of them was unused, and Ken Thompson decided to start using that machine, bring to life a disk controller pack that he had there. And like he described it in a recent interview, before he knew it, he had a disk driver and an operating system around it. And that actually became Unix. Unix was originally written on the Pidp-7, a pretty primitive machine, but very quickly was brought over to a Pidp-11. And by that time, the programming language C was born, and the whole future can be drawn from that point onwards to your Apple iPad, iOS, your Android system, whatever. All these systems are basically Unix underneath, with the exception of Windows, clearly. And there's amazing heritage and similarities of these machines going back to that first Unix-based Pidp-11. So it's an interesting machine from that historical perspective. And the weird thing is, there's a fan base of these machines that I guess grew up using them back in the day, in the mid-70s. And at a certain age, you get attached to things and you never really let them go in life. So there's endless amounts of websites with historical software, historical manuals, pretty much everything that these machines had around them is still available for download on the web these days. So the weird thing is, if you write yourself a Pidp-11 emulator, then the operating systems and the documentation and the application software is all just there. And that became part of both the Pidp-8 or the Pidp-8 and the Pidp-11 project, to make not only a simulator that nicely blinks the front panel like the old one did, but also have there on the SD card, a whole software museum with all the software, and trying to get it alive again. So you get into dozens of little side projects, and there's really a community around these things now. Side projects like hook up a little vector display to play the very first video game again. Somebody did something insane like write a C compiler for the Pidp-8, which technically should be impossible but wasn't. There's all sorts of projects going on, and that's nice because it keeps that memory, that experience of these machines alive. And that was actually the whole retrofitted purpose of this project. To be honest, the project started because I wanted a cheap little replica for myself, and then afterwards I thought, okay, how do I justify this? And the justification is keep that community, keep that memory to these machines alive.
Now, if somebody actually wants to build one of these kits or buy one of the kits, I guess, first off, what's the process for that?
Oh, it's kind of simple. You go to my obsolescence guarantee website and you drop me a message or you leave me a message. And I tend to build, let's say, a batch of the Pidp-8 and Pidp-11 kits every month. And so I'll send you a link with an order form once I have them ready to send out. And the building is not particularly complicated because, of course, in truth, there's Raspberry Pi, this little sort of credit card sized computer that you can buy for between $5 and $35. That's really the brains of this machine. It runs a simulation of the Pidp-8 or the Pidp-11. And the hardware that I attach next to the cosmetics of the case and the front panel and the switches and whatnot is a fairly simple circuit board that brings out these blinking lights and these switches. So it's a couple of hours of soldering and you're done basically.
And about how much do the case or the kits go for?
So the 8 is $165 because it's a bit simpler, and with the Pidp-11 that's $250. And actually, I hated the $250 price tag, but the background there is that I had inadvertently made some money with the Pidp-8. This was always meant as a sort of open source hardware hobby project. But I sold like 2,000, not 50 of these Pidp-8s. So all of a sudden I started making some money. And I decided to invest that into a very ambitious version of the Pidp-11. So injection molded case, injection molded switches. It became a little bit of an insane project, certainly for what still is a hobby project. It got well out of hand financially. But an injection mold for a case is a very expensive thing, certainly in small quantities. So hence the $250 price point. I should, by the way, say that you don't particularly need the hardware. If you're just interested in the software aspect of these old mini computers, you can just download the software from my website and run it on any Raspberry Pi. And clearly you are what you could call blinkenless. There's no blinky lights attached. But the operating system still runs, the software still runs. You can have a look around that way on the budget.
So you can still experience it for the cost of a $35 Raspberry Pi and a download. And what operating systems does the Pidp-11 run that you can try out on the Raspberry Pi?
So if you download that software package that I made for the Pidp-11, there's a whole bunch of them. I mean, there's Unix version 5, Unix version 6, which is interesting because there's a quite famous sort of self-study book that goes through the source code of version 6. And it's a very clean version of Unix. There's Unix version 7, which is the first one that you would recognize and be comfortable with. There's 2.11 BSD, which is a really nice Unix version. Almost as user-friendly as a modern-day Linux, but then without the bloat and the confusing excess of configuration stuff that we have these days on Linux. There's Ultrix, and so that's sort of the lineage of Unix. And all of that actually was sort of collected and cleaned up and polished up over the last few years by a group called the TUHS, the Historical Unix Society, that basically started to collect tapes and disks with old Unix data on it. And basically they were able to reconstruct all these old Unixes. And by now, there's whole websites explaining how to configure them, how to use them. And it is quite weird. I mean, if you look at sort of the high point of Unix evolution on the Pidp-11, and that's sort of circa 1982. Pidp-11s had a very long life. That's 2.11 BSD. That's actually advanced enough that someone a couple of weeks ago wrote a web server. So you have your little Pidp-8, and imagine it really simulates hardware anno 1975, and yet that software is still soft and emulated hardware is still competent enough to bring it online and use it as a web server even today. As a low volume web server, I should admit.
Yeah, but that is pretty impressive and pretty interesting. It sounds like a fantastic learning tool. Do you have any plans for any other kits?
Yeah, I think for me this was a progression. Starting out with my own frustration of having these huge, very expensive, even today boxes that are too big to own, the real ones. So let me make a little fake 8 and study it. And so once I had sort of fleshed out the Pidp-8, I moved on to the Pidp-11. And clearly that's a special one because of this sort of Unix birthplace aspect to it. There's another famous Pidp that I would love to build, and for sure I'll have a replica of that. And that's the Pidp-10. And although 10 is less than 11 as a number, as a machine, that's quite the opposite. The Pidp-10 sort of came close to being a mainframe rather than a mini computer. Many sort of early computer pioneers from the mid 70s started out hacking the Pidp-10. It was a big thing at MIT. It was also the machine on which the Microsoft guys wrote their original Microsoft software. So Bill Gates and Paul Allen started out as teenagers sort of hacking Pidp-10s that you could dial into. Got familiar with them. They discovered that the microprocessor was born, the 4004, if I'm not mistaken. By the time the 8080 microprocessor came out, they decided, this thing needs a BASIC. They didn't have the microprocessor, so they wrote themselves a computer simulator, computer emulator on the Pidp-10, wrote a BASIC interpreter in there. And apparently they were good enough coders that they wrote it on the simulated hardware, brought it up for the first time on a real 8080 microcomputer, the alto year. And it just ran without bugs, which is kind of astonishing. So this Pidp-10 is also quite a glorious, mythical machine. And that's the next one I would like to replicate. And then I think I should look for a more normal hobby afterwards, maybe.
Well, Oscar, thank you very much for talking with me. It's been a pleasure. Next, I'll talk with a developer from the Living Computers Museum Plus Labs in Seattle. I'm here with Josh Dersch. Josh is the Senior Vintage Software Engineer at the Living Computers Museum Plus Labs in Seattle. He repairs and maintains vintage hardware for the museum, as well as creating emulators of some of the systems. Josh has written 2 emulators for historical Xerox machines with critical significance in computer development. Josh, what are these machines and why are they significant in computer history?
Well, the emulators I wrote are for the Xerox Alto and the Xerox Star. And these are significant machines because, the Alto was really used as a research vessel for computing that we take for granted today. And the Xerox Star is an interesting flop in that it shows where Xerox went from the Alto to try to commercialize on the things that it learned from the Alto. But it shows and it kind of defined early graphical user interface desktop metaphors, but ultimately was not successful in the marketplace for a variety of reasons.
So what was the origin of the Alto?
The origin of the Alto was that in the early 70s, Alan Kay and a number of other researchers at Xerox PARC were interested in researching computing, object-oriented computing, and also computing involving children. How could they get children to understand the language of computers? How could they get them to interact with them, and what would be the success metrics around that sort of thing? And as they researched that, they came up with a language called Smalltalk, which is one of the earliest object-oriented programming languages. And Alan Kay had a vision of a computer called the Dynabook, which was a handheld computer with a screen and a keyboard built in, not too dissimilar from modern-day tablets, except, of course, in 1971, such a thing was completely impossible. But he wanted a computer to be able to experiment with the kind of things that you would do with a computer like that. And what he wanted was a computer that was personal. It had local storage, local display, and that was highly interactive. And at that time, Xerox PARC couldn't get permission to build this machine. His management said no way. But his manager went off on a hiatus for a number of months, and while he was gone, one of his coworkers came to him and said, "Hey, we want to build a computer for doing other kind of research, and this, I think, the idea we have here could be used for your interim Dynabook," which is what he called the prototype that he wanted to build. And we think we could knock it out in just a few months before before management gets back. And they did. In early 1973, they had a prototype Alto up and running, and they had Smalltalk running on it almost immediately. And that was kind of the genesis of the Alto. And from there, they used it to research all manner of different ideas, from networking, graphical user interface, object-oriented programming, document editing, including WYSIWYG and laser printing. And there are even some early phone over Ethernet ideas. They actually invented Ethernet at Xerox PARC on the Alto as well. So you've got just a huge expanse of things that they did a decade or more before anyone else got close.
And roughly how many of them did they make?
That's difficult to say. I've had conflicting reports. The word on the street is about 2,500. I've heard as many as 4,000. They did an initial run of them. They only made a couple dozen of them. They grew in popularity, and they continued to do runs. And they kept doing runs until the 80s of them, just as people needed them and wanted them. And they were used at Xerox PARC and at Xerox offices around the world. There were some installed in the White House. They were given away to universities and other research institutions for experimentation. I think it was CMU had one that was set up to monitor their Coke machine with a graphical display about the status of what was currently installed. So some of the uses were more frivolous than others.
So if people want to try out the emulator, they can get it on GitHub, I assume, from your GitHub. And then there's also a version called Contra Alto JS, which is on the web as well. Is that right?
That's correct. A friend of mine did a port of Contralto to JavaScript. It's a few versions behind the version on GitHub. It was more of just a proof of concept. It completely works, and it's an interesting way to play around with it, but it's not as full featured as the one that runs natively on your computer. The version on Windows has a graphical interface, and the Linux and Mac OS versions have a command line interface for interacting with the emulator.
So now the Alto, even though it was a very early graphic computer, you still had it started off from the command line, and then you'd run these programs. What are some examples of programs that were available for the Alto?
We'll start with Smalltalk. Smalltalk was a kind of just a all-encompassing programming environment. You started it up, and then the command line went away, and you had a very early graphical user interface. You had windows, and you had scroll bars, and there was no desktop metaphor. Some programs featured icons and things to click on. And that was the entire environment was written in Smalltalk, and you could bring up the source code for everything in the system, edit it inline, recompile it, and everything would be changed on the fly. And that was a big research vessel for the language research group at PARC. Bravo was an early WYSIWYG text editor developed at the helm of Charles Simonyi, who you might know went on to work at Microsoft and created Microsoft Word. Bravo was, like I said, WYSIWYG editor. What you saw on the screen was what you got when you printed it to a laser printer. And the laser printer was also invented at Xerox PARC, and laser printers, the first laser printers were just big old Xerox copiers with an imager installed in them, and they were driven by another Alto that was connected to the network, and you could print your documents over the network to your laser printer, much like you might do today in your workspace. There was an email client called Laurel, which kind of, if you look at it today, it looks just like what you'd expect an email program to look like. You have a pane at the top that lists your emails that you have read and unread, and there's a pane at the bottom that shows you the contents of the email or whatever email you're composing. And it talked to a mail server, and you could send mail over Xerox networks and later over the internet to other hosts. And it's well ahead of its time in terms of a mail client as we think of it today. There were a variety of games. A few of them came out of Xerox itself. A lot of them came out of the universities where Xerox Altos were donated, because you got students with a lot of time on their hands. So there were Avi Tevanian, who went to work for Next and is currently at Apple, I believe. Wrote a Missile Command game. It was an excellent clone of the arcade game, and there was also a Defender clone, which I have not seen. It doesn't appear to have been archived anywhere, but I'm hoping someday it does turn up. And there was also Maze War, which was a game that came out of NASA in the early 70s, originally on the IMLAC PDS-1 terminal, but made its way to Xerox, where it seemed like a natural fit for the Alto due to its networking capabilities. And so you have one of the earliest, if not the earliest, networked third-person shooter or first-person shooter games. You're a little guy in a maze, and you're trying to find your friends in the maze and, shoot them.
So after the Alto, then came the Star. What did the Star add to the Alto?
The Star was an attempt to commercialize upon some of the things that they had experimented with on the Alto. The Star itself, the hardware took a few of the ideas that they had implemented on the Alto, a task-based microcode CPU, the graphical display, Ethernet, local storage, and all of that. But the intent of it was Xerox wanted something that was kind of more of a vertical integrated solution for an office. It was kind of the paperless office, in the early 80s. You would buy one of these Xerox, or not one of these, you'd buy a set of these Xerox Star workstations, you'd buy a network server, and you'd buy a laser printer or two. And for the mere cost of, $250,000, you would have a paperless office where you could your work could all be done electronically, exchange emails, exchange documents, print everything. So the Star was really intended to be like an office solution for document composition, for communication, and for producing high quality output. And that did, that kind of stemmed directly from, say, Bravo, but it was much more sophisticated and much more integrated. They didn't intend it to be a general purpose computer. Under Viewpoint, you didn't get a command line, you didn't have a programming environment, and if you wanted to do development for the Star, you had to shell out a fair amount of money. The Star was also sold as the 1108 AI workstation. And in that configuration, it ran a programming language called InterLisp-D, which was a variant of InterLisp, which is a Lisp variant developed at Xerox. And that was a general purpose programming environment. You programmed in Lisp, and you had access to all the hardware and all the documentation, and you could do whatever you want. And in that market, it tried to compete with other AI workstations from Symbolics and TI and LMI. It was far cheaper than any of those, but it was also not quite as capable.
And so one of the interesting things about the Alto, I guess, is that it has a page display, and I think the Star has a square display. Do you know why they switched, or any of the intricacies of that?
So the Alto had a portrait display, and that was one of the ideas that came from Alan Kay and his research at Xerox PARC. He wanted a display that mimicked a piece of 8.5 by 11 paper, which is another reason why the text is generally black on white as opposed to white on black, which would have been more conventional at the time. The Star moved to a landscape display. It's not square. It's a 4 by 3 aspect ratio, just like most computers were, until the past decade or so. And I don't really know the reason for the change. I assume that they just wanted more space to display information. The resolution of the Alto was 606 pixels horizontally by 808 pixels vertically, and the resolution on the Star is 1024 by 840. So you can see that it's got the same a higher vertical resolution than the Alto did. So you could display the same amount of information that you could display on the Alto, and then have a little bit of extra space over to the side for more information. That would be my guess, but I don't know if there was a technical reason for it, or what they looked at before settling on a portrait display or a landscape.
And then Viewpoint was sort of like it had folders and icons and all of that. It looks almost like a Macintosh.
Well, you could actually say that the Macintosh looks kind of like Viewpoint. The Viewpoint was the name that they gave it after they realized. So originally the operating system was just called Star, which was great when the computer was also called Star. But later on, they made different versions of the hardware that weren't called Star anymore, and so they renamed it to Viewpoint. And later, when they moved off of their own custom hardware and had this environment running on, you could run this environment under Windows, you could run it on Sun OS, Solaris, and you could run it, I think, a couple other places. They called it Global View. But Star was their graphical user interface that they started working on, in the late 70s and early 80s for this, and it is one of the things that you have that story of Steve Jobs and Bill Gates and all of those guys going over to PARC to look at what they've been working on. They saw Smalltalk, but they probably also saw early versions of Viewpoint running on the Star or something similar, which is where some of the inspiration for the Macintosh certainly came from. And yes, the Star OS Viewpoint had an early desktop metaphor with icons and folders, but it was much more keyboard oriented. You had a mouse pointer that you could use to click on things and select things, but you didn't drag icons. You used the keyboard, which had a number of specialized keys. You had keys that had labels like properties and copy and move, and so you'd click on an icon and hit copy, and then it would ask you to point at a destination folder, and you'd click there, and it would copy the file or program there. So it was highly integrated with the keyboard, and the expectation was that this special keyboard would help make your day-to-day tasks in the environment faster.
So, and if people want to try the Star emulator, it's called Dark Star, and they get that off GitHub as well?
Yes, correct. There's for both Contralto and Dark Star. If you look on the releases tab on our GitHub page for the project, there are downloads for Windows and Linux. And the Mac OS port of Dark Star is not available yet. I'm in the middle of working on that, but it's coming, hopefully not too long.
So tell me a little bit about the Living Computers Museum Plus Labs in Seattle. What's the origin, and what is the museum's mission?
Well, the origin is really that about 15 years ago, maybe a little bit longer than that, Paul Allen wanted to get a Pidp-10 system running because he used one of those, when he was at Harvard, and he used one of those when in the early days of Microsoft for software development. He wanted to recreate the environment that he had used to build, and so he hired a couple of engineers to work on restoring one and get it running. And it kind of ballooned from there into, well, can we make this stuff available to the public? Can we open up a museum? The number of systems that were online and working grew. There was a VAX, and there was some Pidp-11s and a Pidp-8. And so it was thought, well, let's make a museum out of it. And the idea behind the museum is really that all of the machines that we have on display, except for a few that are just static displays, for examples, are up and running and interactable. You can walk up to a machine, sit down at a keyboard, and start typing and do what you want with the machine within reason, and get a feel for what computing was like back in the 60s, 70s, and 80s. And we have everything from large mainframe supercomputers like the CDC 6500 to something maybe a little more familiar like the Commodore 64.
I saw in some of the photos on your website that you guys have a Cray 1. Is that functional as well?
The Cray 1 we have is unfortunately not functional. Most of the boards in it were stripped out at some point before we received it. So it is a static display, but it's very cool to look at. We do have other Cray hardware that someday we hope to restore, but we do not have a working Cray at this time.
From what I understand, they're very difficult to get running.
Yeah, the big thing. So we have a Cray 2 that we are hoping to restore to running condition at some future date. The Cray 2 draws something like 150 kilowatts of power. That's a city block or two.
Wow.
And it's a unit that's it's not small, but it's not gigantic either, and it weighs with coolant in it about 6,500 pounds. So you have to have a special floor to support it. So when we restore something like this, it's not just a matter of, well, we're going to go through the electronics and get everything running. It's a matter of, well, we need to get permission from Seattle Power, and we need to get the building reinforced and a special floor put in, so it's not a small undertaking by any measure.
And what do both you and the museum have on the horizon?
Well, I'm looking into doing some more emulation. I haven't decided what yet. I'm looking kind of in the area of Lisp machines. I would be interesting to do a Lisp machine emulation. As far as hardware, we've got a number of things kind of sitting dormant, but we don't have anything major at the moment. There's we're bringing we have an IBM 36091 panel on display that's just been kind of blinking its lights, because all that remains of the machine is the panel with several hundred lights on it. But we're working on integrating that into the Hercules emulator, which is an emulator that emulates the IBM 360 so that it can, look more authentic. And let's see, what else do we have going on? Currently we're there in the process of restoration is a DEC KA10. That's the original Pidp-10. Which is something that we've had on our list for years, and we finally got one from Sweden, and it was shipped over here this past summer, and it's been undergoing restoration for the past few months, and it's getting very close to operational.
That all sounds very exciting, and I'm sure if people are in Seattle, they should go check out the museum. Thank you very much, Josh, and it was a pleasure talking to you.
Likewise, thank you very much.